Hello and welcome back, guys. I am Coach Williams, or Mr. Williams, and today we're going to be looking at the embedded assessment number 3 from Unit 2. All right. I just wanted to remind you, in case you're not sure, the embedded assessments are supposed to be a review activity, giving you a chance to practice what you've learned in the units prior. This particular embedded assessment, it comes at the end of Unit 3, so it's actually covering the activities that came right before that, and so I wanted to cover that material first to make sure we know what we're talking about before we get to the actual activity. So the two main topics that were covered prior to this embedded assessment are properties of triangles and points of concurrency. So I wanted to run through what those were really quick for you to make sure nobody's lost. So properties of triangles, I listed the three main theorems that are in that section. Triangle sum theorem, which basically states that the sum of all three angles of any triangle are going to add up to 180 degrees. And most of you are comfortable with that. Maybe you just didn't put it in English yet, but that's basically if they give you two angles and they ask you for the third, that's how you solve it, because you know that all three have to add up to 180. Exterior angle theorem is kind of a new idea, and it basically means that if we draw an auxiliary line, or if we extend one of the lines of the triangle, and so I'm going to draw a picture for the exterior angle theorem. Basically, if we have, let's say, a triangle drawn like this value out here, we'll call it x, yeah, is going to be equal to the sum of the interior angles that are opposite of it. All right, so this angle A and angle B here are going to add together to give you x. And it kind of makes sense when you picture it. This would have to be a linear pair with this angle C here. So if we call this C, x and C would be a linear pair. Well, A, B, and C have to add to 180 as well. Therefore, x would be the same value as A and B. So the exterior angle theorem basically would say the measure of angle x, this has to be equal to the measure of angle A plus the measure of angle B. Hopefully that makes sense. Again, this is just a real quick review. Isosceles triangle theorem. The isosceles triangle theorem, most of us know what isosceles triangle is. It's the understanding that two sides of the triangle are congruent. Now, could you have an equilateral isosceles triangle? Technically, yes. Okay, and I'm throwing that out there just in case it comes across your mind. Isosceles says that at least two of the sides are the same. So this would work. So with equilateral, they're all the same. This property would still fit with equilateral. In fact, equilaterals are equal angular as well, in case you didn't realize that. What the theorem says, though, is it's not actually talking about the side lengths. What it says is that if you have two sides that match, okay, we're going to have these angles right here are going to be called the base angles. So base angle is right here and right here, and this is called the vertex angle. Just some vocabulary. The isosceles triangle theorem says that the base angles are congruent. Now, what does congruent mean? Equals. Okay? It means that if this is 40 degrees, this has to be 40 degrees. And if these are both 40 degrees, this has to be 100. What it means for an isosceles triangle is that if you know a single angle, you can actually find all three, as long as you know whether or not that angle is a vertex angle or a base angle, okay? And again, that's all review, so hopefully you're like, oh yeah, I did that in the last section, we're good. The next ones I want to talk about, everybody's favorite section in the whole book, points of concurrency, okay? So I wanted to go over some main ideas, some real quick thoughts for you for each one to maybe help clarify what they are. The orthocenters, the first one is the intersection of the altitudes. Altitudes being like when you draw a height, right? And a height has to be perpendicular. So the altitudes are going from a vertex perpendicular to the line across from it, all right? So in this case, I drew a right triangle. Notice going from this vertex straight down would be perpendicular to this base. From this vertex straight over would be perpendicular. And then from this vertex straight over to the other side. And where they intersect at is called the orthocenter. Now, notice I said location is based on triangle type. For the orthocenter, if it is a right triangle, it's actually on the triangle. In fact, it's at the right angle. The orthocenter of a right triangle is going to be right there at the right angle. It's kind of nice. It's a really nice little bonus thing. If it is an obtuse triangle, the orthocenter is going to be outside of the triangle. If it is an acute triangle, the orthocenter is going to be inside the triangle. It moves as the triangle shape changes, okay? And there are some interesting videos if you want to watch them online as far as them playing with the graphics and stuff, but this is the main idea, okay? And for orthocenter, that is the one you need to know. How do you find altitudes? Well, remember a couple sections ago, you worked on finding equations of lines that were perpendicular going through a certain point. Bam. You're looking for lines that are perpendicular to the opposite side going through this vertex, okay? And so you would have to do that 2 times or 3 times, depending on whether or not you're going to draw all 3 or just 2 of them. Okay, centroid. Centroid to me is one of the coolest ones. It is the intersection of the medians. Medians basically means that it goes from one vertex to the midpoint of the opposite side. So that's why you'll see that I drew basically going from the vertex to the midpoint of this side, making these 2 parts equal, vertex to midpoint, making these 2 parts equal, vertex to midpoint, making these 2 parts equal. Those are called medians. It is the center of gravity. So let's say you had an art piece that had a triangular shape of metal that you wanted to hang from a string. Finding the centroid would allow you to hang it from that string in one perfect point and it would stay level, okay? Or maybe you're building a triangular tree house and you want to know where exactly you should cut the hole for the trunk of the tree so that the gravity is distributed equally. That's what your centroid is your center of gravity, all right? It's always inside of the triangle because of the way it's designed. And what's kind of cool about it is the average of the coordinates, meaning that you can literally take the 3 x values, x1, x2, and x3, add them together and divide by 3, and that's the coordinate of the centroid. Same thing with the y values. y1 plus y2 plus y3 divided by 3, that's going to give you the y value. So this is the one that you'll see most commonly. They'll ask, hey, what are the coordinates of the centroid? And it's because it's so easy to find. You just use the average of the coordinates, all right? Circumcenter and incenter kind of go together. The circumcenter is going to be the center of a circle, okay, that the triangle is inscribed in. Meaning that basically if you were to draw a circle around the outside of that triangle where the vertices of that triangle were on the circle, the circumcenter would be the center of that circle. It is created by drawing the perpendicular bisectors. Again, perpendicular bisectors. So basically what we're doing is we're cutting all the sides of the triangle in half and we're intersecting at 90 degrees. How would you come up with the equations of those lines? Well, think about it. You would find the midpoint and then find the slope of a line that's perpendicular and you combine those 2 things. Where is it going to be? Circumcenter is another interesting one that changes based on what type of triangle it is. The circumcenter is going to be on the hypotenuse of a right triangle. On the hypotenuse of a right triangle is going to be outside of an obtuse triangle, and it's going to be inside of an acute triangle. Okay. The incenter. The incenter is what happens if we were to draw a circle. Basically, it's the biggest circle that you could draw inside of a triangle, where the sides of the circle actually touch the triangle. Okay. With the circumcenter, it is equidistant to the vertices. All right. Whereas the incenter is equidistant to the sides of the triangles, okay? And so if we're trying to imagine a situation where these would matter, imagine you're trying to set up a sprinkler versus a cell phone tower, right? Let's say you have an island and you want to set up a cell phone tower, and you want to make sure everybody on that island gets cell service, but you also want to make sure that you're putting out the least amount of broadcast possible to save money, right? So you would go with the circumcenter, because the circumcenter is going to tell you the magic point on that island where you're going to reach all 3 corners of that island, but not be going too far, okay? And so the circumcenter will let you do that. The incenter, however, let's say you have a triangular garden in the middle of a parking lot, and you don't want to water the concrete. The incenter would be where you put that sprinkler, so that when that sprinkler sprays in a circular pattern, it doesn't actually spray on the concrete, but it's covering as much of that garden as it can, okay? Hopefully that makes sense. Again, that's here. You can always pause this video, take pictures, put it in your notes. I would suggest if there's anything up here that you don't have in your notes, you go ahead and put that in your notes, because it is a very useful thing to have. Okay. So let's talk about page 203. If you have not worked page 203 and really 204 yet, because there's a question on 204 as well, I want you to pause the video and go do page 203. It's okay, I'll wait. I don't mind. Go ahead, go do page 203. All right, welcome back. So on page 203, I've got the drawing up here. Basically, they're giving us a triangle, and they're asking us to do some work with it. Now, that's not what they say, right? What do they call it? They say that they're talking about a city park, and they're talking about some information about the park that they want to figure out. And so here we have a triangular park. Here are the coordinates. We've got C is 1, 1, B is 11, 1, and A is 6, 8, okay? And I'm just going to walk through how to do these problems. If you look at question number 1, there are 4 parts to it. So here we're on number 1. We're going to have part, and I'm going to call them A, B, C, and D, even though the book does not do that. They just give you points, but I'm going to do that just to kind of keep them separated, because I think it's easier to stay organized. So the first question it says is, what are the actual side lengths of the triangular plot of land? So how do we find side lengths? Well, side length means distance. So we're going to do distance formula, okay? Distance formula for me in geometry, I use kind of a Pythagorean theorem idea, and I look at how much did the x value change. So from 6 to 1, or from 1 to 6, what's the change? That's a change of 5. So I'm going to say 5 squared plus, how do you get from 1 to 8 or 8 to 1? Either way, it's going to be 7 squared. and then I'm going to square root that. Now, some of you are like, wait, what is he doing? That's the distance formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. That's this, okay? It's just kind of a shorthand version. And this is going to be for AC, yeah? So 5 squared is 25, 7 squared is 49, 49 plus 25 is 74, square root of 74 is not going to be necessarily a pretty number, and that's okay. So depending on where you're at, square root of 74, maybe square root of 74 is enough for you, depending on who your teacher is, whether or not they're okay with that. Square root of 74 might be enough information. Now, they might want you to reduce that. How could we reduce that? Well, think about it. How do you get 74? 74 is 37 times 2, okay? 74 is, there's nothing to reduce there. 37 times 2, those are both prime numbers, so it doesn't go any further. So the only other thing you might do is you might put it in a calculator. And I don't like this, but I'm going to just clarify to make sure we know where it is. Square root of 74, you put it in a calculator. I don't know what it gets, so I'm not going to write it up there, okay? I'm going to tell you that it's going to be between 8 and 9, right? It's going to be between 8 and 9 because it's between 64 and 81, probably about 8.6, something like that. But I don't know exactly what it is, and I'm not going to worry about it. This gets me close enough. So really what I'm going to do, we're going to erase that, and I'm just going to put square root of 74 here because I think that's the best answer for AC. Now, let's talk about AB. So let's go ahead and do AB. And so what would I use for AB? Well, I'm going to go from 6 to 11, change to 5, 8 to 1, change to 7. So notice I get the same thing, 5 squared plus 7 squared. So I'm going to get square root of 74. Now, some of you are like, wait a minute, that seems kind of weird. What's happening here? Well, realize that if you have two side lengths that are equal, what do you have? You have an isosceles triangle, okay? And if you have an isosceles triangle, think back to what did we do with isosceles triangle? The base angles are equal, okay? We'll get to that in a minute. Let's go ahead and finish up what we were doing. Let's talk about getting CB. CB is a really easy one. I'm going to go ahead and show what it would look like this way. We're going from 1 to 11. That's a change of 10. And then we're going to go from 1 to 1, no change. I call that 0, right? That's what we say in math when there's no change. So 10 squared is 100, square root of 100, which hopefully most of you know is just 10. So CB is actually 10. So those are my three side lengths. That's what they're asking me to get in A, or the first part of question number 1. The next thing it asks is the type of triangle formed by the intersection of the three streets. Well, we already talked about that. If two sides match, we call that isosceles. Sorry, I teach math, not spelling. I always pause for a second there when I'm trying to spell. My mind kind of has to shift. Next thing is the amount of fencing needed to surround the city park. So if we're talking fencing, all we're wanting is perimeter, yeah? And perimeter you just get by adding the sides, okay? So I could put 10 plus 2 root 74, because that's really what happened here, is I'm going to have to add 2 of the isosceles, the sides that match. I have to add those. Now I told you that would be about 8.6, and so if I do 2 times 8.6, that's going to be 17.2 plus 10. It's going to be approximately 27.2, okay? Maybe 27.3, somewhere in that range. Again, that's a calculator thing if you want that. This right here is your exact answer. Okay, now I understand if you go to Home Depot and ask for that much fencing, they're going to look at you funny. So there is a need sometimes to get that rounded decimal, and you're welcome to do that if you want. Number D, or the fourth thing there, it says the actual measure of each angle of a triangle. Now wait a minute, we even talk about lengths, right? Well, another thing they gave us at the beginning of the page is they actually told us angle A and they told us angle C. They didn't call it A, they called it CAB, and they called it ACB, okay? But we have to remember this, the isosceles triangle theorem. So we have to know that this angle over here is going to be equal to this angle over here. So that means this is going to be 3x plus 12.5. And then we also have to remember triangle sum theorem, meaning we're going to add all the angles together. So I'm going to do 5, and I'll write it down here for D since it goes with D. We're going to do 5x plus 1 plus 3x plus 12.5 plus 3x plus 12.5. Again, you could write that as 2 times all that. Doesn't matter. I just wrote it all out. And we know that for every triangle ever on the coordinate plane, that's going to be 180 degrees. Okay? Now, what do we do with that? We combine like terms. We take our x's, 5, 3, and 3. We put them together. We get 11x. We take our numerical values, we've got a 1, we've got 12.5, we've got 12.5. 12.5 and 12.5 together is 25, plus 1 is 26. That's going to be equal to 180, okay? And then we work it out, we solve it. We're going to subtract 26 from both sides, we're going to get 11x equals 156, right? And then if we divide by 11, what are we going to get? 11 times, oh, we get a fraction, interesting. So we're going to get x equals 156 over 11, okay? And I would leave it just like that. I am okay with it being a fraction. I don't have any issue with it being a fraction. Fractions are okay. Fractions are my friend, okay? And you can put the decimal if you wanted. So that is question number 1. Let's talk about question number 2. Question number 2 is on the back. Question number 2 is on page 204. And question number 2 is dealing with the points of concurrency. All right, they're going to use the same triangle as far as points of concurrency. Or, I'm sorry, they're going to use the same triangle we used in number 1, but now we're going to talk about points of concurrency. So the first thing it says is, the centroid of a triangle is its center of gravity. We talked about that earlier. A fountain will be placed at the centroid of the park. The designer wants to place a stone path from the fountain to the midpoint of each side. Okay? So they want you to reproduce the diagram. I'm just going to use the same diagram because, you know, why not? Maybe we'll go ahead and erase this part on the inside so we can kind of see what we're doing. So we'll erase the x's. Okay. So it says they want to place a stone path from the fountain to the midpoint of each side. So that means if we're talking about centroid, how do we get centroid? Where we at centroid? Medians. So it means we're going to the middle of the other side. So probably going to be somewhere in here. And I'm just rough sketching it. I'm not actually trying to find it. I'll find it here in just a moment. But I'm just rough sketching it. And then I understand there's going to be a stone path going directly. Is it to the midpoints or is it to the side? Stone path to midpoint of each side, yeah. And so stone path to midpoint to each side. And so what they're wanting us to do is work with that. They're going to ask us first to mark congruent segments in your diagram. So that means if I'm going to the midpoint, this section equals this section. Well, remember, this whole side equals this whole side, so half of this side is going to equal this side as well. So all those values are actually congruent to each other. So you have these 4 parts are all equal to each other. And then on the bottom, we have a different length. When we divide the bottom, it's a different length, okay? And we could find that actual value, right? We could divide by 2 here, divide by 2 here. That would give us each of our values. And then divide 10 by 2, you get 5 and 5. So we could find those values. Now let's see what they ask us to do next. What are the coordinates and location of the fountain? Now, do we remember how I told you how to get the centroid? You take the average of the 3 points. So let's take the average of the 3 points. So I'm going to put A on here. And I'm just going to put a check because we did our drawing. And I'm going to put B. What are the coordinates of the centroid? So I'm going to add together the x values. So I'm looking for an x comma y. What that's going to look like is I add the x values. So I have 1, 6, and 11. 1 plus 6 plus 11 over 3. That's the x value. And then I'm going to have my y values. So what are my y values? I've got 1, 8, and 1. Yeah? Everybody okay with that? So 1 plus 8 plus 1 divided by 3. So 1 plus 6 plus 11, that's going to give me 18 over 3, which is equal to 6. 1 plus 8 plus 1 is going to give me 10 over 3, which is equal to, what, 3 1/3? These are the coordinates of my centroid, all right? My coordinates are going to be 6 for the x value and 3 1/3 for the y value. And I did 3 1/3 versus 10/3. I'm okay with 10/3, but if I'm trying to put a point on the graph, the 3 1/3 makes just a little more sense, okay? And that's going to be this value. Notice that this point should fall pretty much underneath the 6, okay, because it does line up. Next he asks, what's the actual distance from the fountain to each vertex? So they're asking you to do distance formula 3 times. Notice the distance from here to this vertex should be the same as this distance from here to here. So I'm just going to do it once, and we'll list it twice. So this point coordinates is 6, 3 1/3. Now we're going to get kind of a funny number here because we're dealing with fractions. But from 1 to 6, we get 5 squared plus from 1 to 3 1/3, we get 2 1/3, or really 7 thirds squared. So we get 25 plus 49 over 9, which is 25 plus 5 4/9. And we take the square root of that. So really we get 30 4/9. We're taking the square root of that. So square root of 30 4/9, not the prettiest way to write it, but it gets you an idea of where you're at. Square root of 30 4/9, somewhere between 5 and 6, probably about 5.4 if I had to guess. But you can put it in that calculator and get your exact answer. And that's going to be true going to C or to B. So this is going to be for C or B. Hopefully that makes sense because it is isosceles. If we wanted to know the distance from the centroid to A, so centroid to A, think about it. You would just go straight up. Straight up how far? Well, how far do you have to go to get from 3 1/3 to 8? Looks like what, 4 2/3? 4 2/3 would be the distance. You don't really have to do much work there. We're just literally going straight up to get to this vertex up here, okay? The next thing it asks you to do is D. I'm actually not going to do D, I'm going to let you do that one. But it's the same idea. D is asking you, hey, how far is it from the centroid to the midpoint? But I don't know the midpoint, so find it, yeah? This plus this divided by 2. Use the midpoint formula. Find your midpoints, find the distance, okay? Hopefully that makes sense, guys. I hope Unit 2 was a successful one for you, and I will see you next time. Thank you.